Okay, it's 4 o'clock. Let's get going. So I have a 15-minute presentation, and the plan is to do another sample test. Now, I'm not going to be pushed to finish all 5 problems here. So I will probably do, I don't know, maybe 3, and then I'll keep the other 2 for our final lecture before the Saturday's midterm, which is going to be Friday at 10:30. Okay. Uh, I did email you. A document about an hour ago, maybe an hour ago. There was an attachment to it which says another sample midterm examination, and there were some messages. Please make sure you read these emails that are coming from Blackboard from my course, because in one of the classes this morning, I think around noontime, the guy asked me, "Did you send us a sample test?" I said, "Of course I did. This is before the break." So how did you send it? Well, I emailed. So I don't know what people expect. I mean, I email these as an attachment, and I have no intention of putting it on the Blackboard. So if you don't read your email, then you probably don't read the stuff on Blackboard. Okay. Are there any questions before we start doing this set of problems? Are there any questions? Okay, none? Fine. So, first problem. There were 5 of them back then. Something like this. Something like that. Okay. If there is a question, please talk, speak. I'm not going to read messages.
People are just saying that the remote desktop isn't working right now.
Yeah, okay. Hopefully you'll get back to work soon. I don't know. I have nothing to do with it. I know that there were some issues with it yesterday and 2 days ago, etc. It was working this morning. And what do you get on that? What does it say? Remote desktop not working means what? You get a message? All right, since you're not answering, that's okay, no problem. Send a message, send an email to Mr. Mark Gryn, Gryn. He's the system administrator. Explain to him what the issue is, and maybe he can help you. Now, I'm assuming you can hear me because this guy didn't answer, so I don't know, microphone not working, you can't hear me at all, nobody can hear me, I'm not sure. So I'm assuming that you can hear me.
We can hear you.
All right. Okay, thank you. Thank you. So you look at this problem, immediately you should realize that this is a hybrid problem. You should not solve this thing with all solid elements, or maybe you do, I don't know, you do it with solid and the beam, but you leave out the shell. We have done enough problems like that, and your eyes are trained so that you know this is a hybrid problem. In other words, this, either that portion or the whole portion, should be meshed with shell elements. That should be done with solid elements, and these with beam elements. So that's all sorted out. Okay? Yeah. And then it says use all planes of symmetry. Okay? All planes of symmetry that are applicable. So you'll have to look at the geometry. Obviously, if the geometry is lacking symmetry, forget it. Okay? But obviously, this does have symmetry. However, you also have to look at the load, and you have to look at the restraints. The restraints is that these two ends are clamped. Okay? And you're applying a force of 50 pounds on that top face. Okay? Think about it. Stare at it. look at your notes, look at the video segments. There is a plane of symmetry, and that plane of symmetry is along that line. In other words, split this thing into two pieces so that one leg is on the one side, the other leg on this side, half of the block, half of the block, half of the shell, half of the shell. So you need to model only half of this. The choice is yours. You can make half of it to begin with, or you can make the whole thing and then start splitting it. In this case, there's only one split, basically. That's up to you. I leave it to you to decide. We want half of this thing modeled, okay? The other thing is that you have two choices. You can do this thing as a single part, or you can do it as an assembly. It's entirely up to you. The video segments that I posted on these hybrid problems, I did it both ways. If you look at those video segments, there's a part one, I did it as a part, single part, and there is a video segment, the latter part of that video segment is done as an assembly. One other thing I want to remind you, if you're doing something as an assembly, you have to not only give us the product, you have to give us all the parts that are used in that product, and you have to give us the analysis file. Any one of them is missing, forget about the mark for that particular product. All right. Now, so let's go ahead and make I'm going to make half of this, okay? So first I'm going to make, for example, I don't know, I'm going to make the block first, and then I'm going to make the surface underneath it, and then I'm going to make the leg, okay? The order is up to you. How you want to do it is up to you, and we leave it at that. So we start with a part. I'm going to do that only as a single part. Immediately save, file, save management, save as, desktop, new folder. I will call this thing sample test. Oh, actually, I'll call it another sample test. Okay. The sample test. All right. And in it, I'm going to make a problem one. How about that? A folder, new folder. I'm going to call it problem one. Okay. Now you can go with your own the standard naming convention and change it at the end, or you can do it from here. Your student ID number, your last name, etc., etc. The choice is yours, but that's the way you're going to do it on the test. Okay. So let me do it like that. 1, 2, 3, 4, 5, 6, 7, 8, 9 is a student ID number. Your last name. How about Bohr. Problem one. I don't know whether you want to keep the part one, you don't want to keep it, that's entirely up to you. Okay, let's make it. So on that plane, I will sketch half of that rectangle, which makes the block, and I believe the block size is 5 by 5 by, oh, everything is 5. Excellent. So I'm going to make it like this. If needed, we're going to come and clean it up. I'll do it like that. 5 by 5, and I'm going to extrude it by 2.5. How about that? Because I need only half of that. 5. This one is 5. Exit. Ooh, wrong one. Okay, so I would have, yeah, okay, so if I'm doing it like this, I better make this thing 2.5 then. Okay. 2.5, if that's the route I'm going. Actually, I want this thing to be 2.5. Okay, this one to be 2.5, and this one to be 5. Look, we don't care how you do it. I just want to do it so that it looks like my problem. That's it. Okay, and then we pad it by 5 inches, and there we are. The other half I didn't model on the other side because the whole thing was 5. Okay, now let me make the plate underneath it. Okay, now you have two choices. You can start from this edge and extrude a surface which is 10 inches long, or you can start at this edge and extrude it by 10 plus 5 is 15. You're not going to lose any marks either way, because in a real life situation, when there is a problem like that, you got to find out what happened. In other words, did they actually bring a block like that and put a surface here and welded it down here, or did they bring a surface and put this thing on it? Okay, for us it doesn't matter. Okay, so in order to create a surface, obviously you have to. Yes. Yes. What can I do for you?
Okay, so can we draw a rectangular and then use the fill function to make the shell?
Yes, you can. Yeah, the different ways of doing it. Yeah, I'm going to do it differently instead of filling.
Okay.
I'm going to take this edge and extrude it. There are different ways of doing it. Yeah, what you're saying is make a rectangle here and then fill it. Of course, you can do that. So you're going to go to generative shape design, and I do extrude. I take that edge in the direction Y, flip it, and by 50. There we are. See, it starts at the other end. Could you have started here and extruded by 10? Yes, you're doing a slightly different problem, but for this course, this problem, these type of problem, we don't care. Okay? Now, then we want the leg. Now, the location of the length of that leg is 8 inches. So I'm going to create a line, point and direction. This is the point. The direction is Z. And flip the direction by 8 inches. Is that 8? Yeah, 8 inches. Oops. What did I do? What did I put here? 8. 8. There. There it is. Save everything. You are told that this whole thing is made out of steel. This assembly is made out of steel. So we apply material. Everything is made out of steel. Therefore, we can apply this to the entire part, and everything is going to inherit that. Okay, very good. Save. Now notice that the cross section of this beam is circular. If that is the case, I don't need an orientation point. Otherwise, I will have to come back and fix it. Okay, but it says it's a circle. I don't need an orientation point. This is good enough. We're going to go immediately to generative structural analysis. CATIA sees a solid object right there. It immediately meshes it. We are doing a static analysis, right? Nothing about frequency calculation or buckling in this test, this midterm. Let's change the rendering here. You can look at the mesh if you want. It's all right. That's fine. Okay. I don't particularly care. And notice that, by the way, when we gave this test, and same instruction for you. It says for finite element problems, use linear element with default element size and sag unless otherwise stated. If we don't ask you to refine the mesh anywhere special, don't do it. Okay, it's up, don't make your life harder. Okay, good. Okay, so this is it. Now we're going to have to we have to mesh the shell right there. Select that. Now I would like to, I don't know, what did I use for the first one? Parabolic, linear, I can't remember. I'll make the other one parabolic. Well, linear, okay, linear, fine, linear. But I do want to, I don't expect you to do it, but I do want to have these things to be reasonably same size. So let me make it 0.5, and I have a couple of words about this. Now, we don't expect you to do that, but if something doesn't run because it says your element is too big, etc., well, then go change it. Okay? We had this issue with an assembly problem several weeks ago. Okay? All right. Good. Let me make sure the other one is also parabolic. They don't have, they're also parabolic. Good. Excellent. The thickness of this shell, 2D property, uniform thickness everywhere. And the problem says it's 0.25. 0.25 inches. Okay. Now we're going to have to mesh the beam there. I don't know, this was 8 inches, so we put 8 elements through the length. That's fine, no problem. Okay, and properties. 1D property. It's not rectangular, it's cylindrical. And the support is right here. Automatically, it picks the correct material, and the size, whatever it was there before, which was 0 before. I can't remember. What am I saying here? It says the diameter of this rod is 0.25, so the radius is 0.125. 0.125. Look. Yeah, right there. And we say, okay, we don't need orientation points. Let's save our analysis. File, save management, analysis, save as. Since I'm lazy, I'm going to do it the long way. 1, 2, 3, 4, 5, 6, 7, 8, 9, dash, bore, B-O-H-R, dash, or underscore, I don't know, problem 1. And if you want to leave that analysis there, leave it. Otherwise, you just get rid of it, whatever you want, and say OK. And it goes in that same folder that I created. Very good. Now, what else do we have here? We know that the load up here is 50 pounds. 50, not pressure. Load is 50 pounds in the direction Z is 50 pounds, minus 50 pounds. And the face is, oh, wait, watch out here. It says user. No, global. That's why I could not close it. Because when it's user, it's going to ask you to pick the user coordinate system. Last time I used this thing, this must have been user, so it stayed like that. Be careful with this. Okay? And I don't know, if this problem had 40 points, you're going to lose probably 10 points. 6 points, I don't know. You know why? You got to speak up.
Yeah,
It should be 25 pounds, not.
Yeah, yes, 25 pounds. Yes, you're absolutely right. 25 minus 25. Okay, very good. 4.5 points for this. Yep, unfortunately, that's the way it is. Now, we have to create connections. Okay, so between this end of that plate, that corner point, and the end of the line, that corner point, we need a rigid connection. First, let's do a connection. Let me hide this. So that is going to be the the corner of that plate. If you had done a fill, F-I-L-L, then you will not be able to pick it. Probably you have to hide the sketch, okay? But I didn't do a fill, F-I-L-L. I did extrude. So the only thing that is basically a line was here. This is fine. Second component, the end of the line. The end of the line. There is the end of the line. We say, okay, if it's bothering you, I can bring it in the front, right there. There's my connection, and this has to be rigid. It cannot be fastened. Now, if you're having a problem, go to the tree and pick it from the tree. Right there. I can pick it from here. Here, I have to move things around, hide things, stuff, etc. And between the bottom of this and the face of that surface, because it says all, oops, wait a minute. Because it says all components are perfectly welded, bonded, glued, etc., we're going to use fasten. Okay, so where is that connection between that face? For the second one, I'm going to hide that. And we're going to make this thing fasten. Where is the fasten? Fasten is the face-to-face connection. It's right there, and it's going to be that. Where's the fastener here? We say OK, and we're going to move on. OK, a couple of comments here. Couple of comments. One is, don't blame me if you get a job and this was the problem that you were doing, and after you modeled it, the guy said, wait a minute, what the heck are you doing here? I mean, what the thickness of this? The thickness of this is 0.25 inches. This guy was 5 inches high. So where are you putting this thing? Are you putting this thing, you know, a little bit up so that the thickness actually covers that entire gray face, or part of the thickness, half of the thickness is down here, loose in the space, okay? Those things are important, but for this course, at this level, we're not going to worry about that, okay? Because there is an inconsistency between the way I'm doing it and the way it actually may be represented in the problem, okay? Or in the real life. Now, can I run it? Should I run it? Run? Is there anything else that I have to do? Okay, what do I do?
I think you're missing a clamp on the beam.
Restraint.
Very good. Okay, so I'll put,
Use a restraint.
yeah, so first of all, I put the clamp here. I did it. No problem. But there's more than that. It will run right now, but it will give you garbage because you're using planes of symmetry. You have not used any restraint for the symmetry. So on this face, surface slider, because it's a solid. And remember, all that surface slider means there is no displacement normal to it, which means no displacement in X. That's all it is, okay? But I use surface slider because I like it better. And this edge of the shell is in the plane of symmetry YZ. So user-defined restraint, let's uncheck all of these. This edge of the shell, oh my God, I'm going to lose 10 marks here.
Shouldn't the surface slider be in the opposite direction?
On the
Yeah,
other
the opposite
side. Yeah, you make that mistake. Unfortunately, you're going to lose all the marks for the restraint. Okay, so I don't want this. I want that side. And for the edge of the shell, this is the one that I have to pick. Okay, so user-defined, this edge still lies in the YZ plane, does not move in X. If it lies in the YZ plane, I just want to make sure. Yeah, if it lies in the YZ plane, does not move in X. Once you know that, rotations are exactly the opposite. So if these two are unchecked for rotation, these two will be checked. That's what opposite means. Okay, good. And hopefully we didn't forget anything. Let's save this. Save it. Where's the save? Oh, floppy's over here. Right. And run it. Run. There are other ways of doing this problem, and I will give you an example once it finishes. Yeah, okay, so this is we know that. This is a warning message because I put a surface slide there, fine. Okay, let's look at the view from the front. Not like that. There's my front. Not like that. My side. That's what I wanted to show you. Okay. Remember, this was a plane of symmetry. So when this goes deflect, it better not go to the left or to the right. So here's the deflection. And animated, it better not go to the left or to the right, that face. And it doesn't. Now I can turn it around. Does that look like what I expect? Of course it is. Okay, so you have a beam here, you put a force up there, it's going to push this because it's fastened to that, it's going to push that, etc. Okay. Now, what do I mean? But you may be doing it differently. For example, you might say if you created the surface here, see that instead of the whole thing, so instead of the whole thing, if you created only this surface, then you create a connection between that face of the block and this surface here, because there is no bottom surface. So there's no bottom. There's no bottom, surface. It's just the bottom of the block. So that face and this face, and again, you make it fastened. Okay. Are there any questions?
Yeah, I have a question.
Yep.
Okay, so it is fastened between the solid object and the shell, but the thing is, the beam here, you
Yes.
chose a rigid connection, right?
Yes.
But in the midterm exam sample that you showed us, it said that all of those are fastened, no?
Yes. No, I said all are perfectly welded or glued or bonded.
Yeah.
Yep.
Okay, so
Yep.
shouldn't they also be fastened then?
Oh, we had this discussion. Yeah, we had this discussion about 3 weeks ago, 4 weeks ago. Fastened. You cannot put fastened on point-to-point connection. It's just that will not take it. It will not take it. As simple as that. Okay. The only thing that it will take is rigid. And when you think about it, 2 points that are rigidly attached to each other, don't you think these are perfectly bonded, perfectly welded, perfectly glued when 2 points are rigidly connected to each other? Isn't that the definition of perfectly welded? It's the same point, basically.
Right. Okay.
It doesn't bother me that you call it rigid, but a point-to-point must be rigid.
Okay.
A point doesn't deform. The point that doesn't change shape, so it must be rigid. Okay, anything else about this problem? All right. So now remember, let me close that. Let me save everything first. What we need from you in this test, if this was one of your problem, you will go to, what is this? Yeah. You will go to that folder that I created, another sample test. I put all of my stuff in problem 1. It is already in the proper format that we wanted to call it. You take this and that, both of them, you drop it in the place in Blackboard which says midterm section 53, problem 1. Drop it in problem 1. Are there any questions? No questions. Okay, good. Okay, so let's go ahead and do the next problem. Okay. Well, first you read this a little bit, and then it says, now your problems, all will say use the most appropriate element. Okay, it didn't say it here. Oh, here, right here. Use the most appropriate element and any parallel symmetry that are applicable. So you read this. What is the type of element that you're going to be using? It is obvious here because of the way I've drawn it for you. It must be shell element. Must be. It's basically it's a thin-walled vessel, pressure vessel. Think about it as, you know, the front of a ship or something like that. Okay. Think about it in that terms, for example. Okay. This has to be done, it must be done with shell elements. Do not do it with solid, because if you do, you're going to lose a lot of points. Okay. All right. Now we have this edge is clamped. This edge is clamped. That's what it says. And there is internal pressure applied here of some value. Are there any planes of symmetry in this problem?
Yes, right in
Can
the
you tell me?
middle plane.
Like that, yeah?
Yeah,
Like that.
longitudinal axial plane, yeah.
Very good. Okay, very good. Now, let me ask you another question since you answered this. If this was a complete cylinder, not half a cylinder, and you did the same problem, is that the only plane of symmetry?
No.
No, you would have to do a quarter then.
Okay, either a quarter or a 30-degree angle or a 45-degree angle, etc. You understand? Okay. Quarter is easiest, but if I told you, if this was a complete cylinder and I told you, hey, use 30-degree sector, then you have to use a 30-degree sector. But in this problem, there's only one plane of symmetry, and this is it. You have two choices. Either make the surface like that, or create make it like that, meaning as symmetry taken into consideration, or make it like this and then cut it. It's entirely up to you. So I'm going to do that by making just a quarter of it. Okay, a quarter means a half of this. Okay, so let's go here. We start with the part file. Obviously, this is the part. Immediately, I will save it. File, save management, save as. I have a folder called another sample test, one level up, problem 2. Create a folder, new folder, problem 2. Problem 2. Are you in pain? Okay, so it goes into problem 2. It sounded like somebody's in pain. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you were bored. And this is problem 2. And if you want to leave the part there, fine. It's just that I don't like it when you say problem 2, part 1. Okay, that's fine. Doesn't matter. Say okay. Now, the way I'm going to make this is not necessarily how you're going to make it. You do it any way you want. I don't care. On that plane, I will sketch. Actually, let me exit that. I want to use a different plane. Let me see what I did. On this plane, I will sketch. Please don't worry about what I do. You do whatever you want. And we may have to do a little bit of a cleanup here, so I'm going to do something like that. Aha. Oops. This last piece I don't want. We're going to control Z. Last piece I don't want. Okay, so I want some dimensions here. I think the dimensions are the length of the sky. I'm going to look at my other screen to see what the length of the sky was. Just a second. Yep, 10 inches. So this is 10 inches. Okay, and this radius was 2, I believe. It says 2. It says diameter, sorry, diameter of this hemispherical cap is 2, which means radius is 1. So radius is 1. 1, okay. Okay, what can I do? That's the way it looks like. And then I'm going to revolve it. Revolve it. Revolve it about the y-axis by 90 degrees. Okay, let's see the 90. See if this looks better. Ah, yeah, there we are. There we are. Well, what happened? I better clean it up here. Oh, there's a problem there. There's a problem in my sketch. Probably it's not coincident. Yeah, okay. So let's go back to that sketch. That sketch, something is screwed up at this end. Yeah, so I want this line, this point, control that to be coincident. So it shifts it up a little bit. Right. The only thing is that this doesn't look right. Oh no, wait a minute. Let me undo this. I don't like what I did here. Let me make that center, the center of this, control that to be coincident. Okay, I guess I have to, yeah, so coincident. Yeah, that's better. The only thing is that I'm not sure what this angle is. Let me see if this point is coincident with that. I'm not sure about that. That control this line, are they coincident? Because there was a hole there. Oh, it looks like now it is. So exit. Oh, right there. Okay, that's what I want, right? This is 1/2 of that gadget that I showed you. 1/2 of it. Okay. I don't think the drawing is to scale, so that's all right. Okay. Good. This is done. Let's save it. Everything's made out of steel here, I believe. Okay, so let's make everything out of steel. We don't want you to, waste time on this steel and aluminum and brass and things like that, unless it's a shrink fit and things like that, or a what is the other one? Bi-strip metal, bimetallic strips or bimetallic contact and things like that. Then you have to do different materials. Okay, watch out for that in case you get one. Okay, so this is it. So let me hide the sketch that I drew because I don't want to do this. Very good. So we're done here. Now we're going to go to the generative structure analysis. CATIA does not see an object, so it will not mesh it for you. A solid doesn't see a solid object, it does not mesh it for you. Okay, so we're going to mesh it with shell elements right there. There we are. Oh, that's gigantic. So let's make it 0.3, see how it looks like. I don't know, linear. Okay, fine. Let's look at our mesh, something respectable. Don't stress out yourself for doing a very small element and things like that. That's just digging. Okay, digging, whatever. Let's deactivate that. Okay, so this end is clamped. Okay. This edge and that edge, they are in the YZ plane of symmetry. So user defined. Let's uncheck everything here. This edge and that quarter of a circle, see, they lie in the YZ plane. Therefore, they do not move in the direction X. And as soon as you say that, rotations are opposite. So if this is checked, that is not checked. These are unchecked. These are checked. That's what opposite means. Okay. And finally, pressure. Pressure right there on that face. Now you got to be careful. Make sure that you put it on that face too, because I just put it there. You can see that if you rotate it around, it didn't take, the direction is wrong actually. Sure. Let me put minus, can't remember what, it says minus, it says 30 psi. So minus 30 to make it point in the right direction. There you go. It's pressurized like this. And don't forget this. If you miss this, unfortunately, you don't get the marks for the load. Yeah.
Can we select two faces with the same move?
If you join them, probably it will work. I don't know. I think, but because they're not joined, okay, you have to. Look, I don't know. I mean, are you asking me? Can I do it at the same time? Is that what you're asking me? Is that what
That's
you're
the
asking
question,
me?
yes.
Okay, I don't know. Try joining it. You can't do it, obviously.
Would it be
Obviously,
wrong? Sorry, would it be wrong to join them in this example?
No. It won't be wrong.
I tried joining them and it wouldn't mesh it. Like when I joined it, it wouldn't let me mesh it.
Okay, let me finish this thing, and then because we're almost done and we still have time, so we're going to come and look at it. Okay? We still have time. Okay? So let me save this thing because this problem is almost finished. So File, Save Management, Analysis, Save As. Now we decided to put it in that folder, problem 2, and the name we decided to give it 1, 2, 3, 4, 5, 6, 7, 8, 9 dash BOHR, BOHR, and it's problem 2. Problem 2. Okay. So you're right. And okay. And I don't anticipate. Oh, thickness. Did I give it thickness? I didn't give it a thickness. 2D property. 0.25, right? Is that what it says? Thickness. I don't know. What did I have? In the statement of the problem, I had 1/10 of an inch. So this will be 0.1. Okay. Very good. Save it and run it. Now we'll see what happens. I don't know. Good. Nothing unusual. Doesn't surprise me. You pressurize that guy. You pressurize this vessel like that. It's going to bend because this is a clamp. It's going to bend. Okay, and it did. So for the purpose of the test, what you need to give us are the analysis and the part for this in the folder on Blackboard which says problem 2, okay, for your own section. Now, okay, so let's see now. Let me save this thing. I'm going to get rid of it. And because I don't want to fool around with this, let me do the following. Let me save it with a different name. File, Save Management. That guy, I'm going to call it Save As, Fooling Around. How about that? Oops, here. Fooling around. Fooling around. Now, a couple of things. First of all, because of the way I made this, remember I drew a sketch here, which looked like a line and a half a circle, a quarter of a circle, and I revolved it, right? The nodes that you're going to get, you don't have to join. Okay, because you're going to get a, you don't have to join because you can see it worked without it, okay? But you're saying that I want to join this and it didn't work. That's what you said. So let's try it. Join that. See, it's already, you see, it's already one piece. Look, it's already one piece. Look, when I select it, look, it's already one piece. So it's just meaningless for me to go and select this and then select that. This is ridiculous because when I select this, it deselects the original one. So do not try to join this thing. But what I could have done was this. So let me do the following. I'm going to kill this. I'm going to kill this because I didn't have to kill it. But let's see. I'm going to do a different way. Part. I shouldn't have killed it. Okay. So on this plane, I will sketch just like before, except that I will draw a line here. Okay, a line, and I'm not going to complete it in the same sketch to be that quarter of a circle. So exit, exit. And then again, on that same plane, I will sketch. Now the quarter of a circle. So let's see what's the best way of doing this thing. So I'm going to put it, okay, so we'll clean it up, don't worry. Let's clean it up. This guy controlled that guy. We want them to be tangent. Okay. And I'm not going to put dimensions because dimension, okay, I have to clean it up here. So this control, I don't like the way I did it, but that's okay. So let me see if I can do this. Okay, this has to go. Delete. Where am I? Okay, on that plane, we're going to draw a second sketch. Now I've got to be careful here because I did a sloppy job here. So there is my circle. Now this is the center. You know what? If it's giving me a hassle, let's go ahead and do it the long way. So there we are.
I think you can just make a point. It'll be easier.
Okay.
Right?
Wait a minute. Say that again. Can you say that again? You mean make
I think
a
you
point?
can just make a point.
Yes, here, right here. Here, you can make a point right there.
Right.
And I'm going to make it coincident though. Wait a minute. This point control that point coincident. Okay? Coincident. Right? That's what you're suggesting. And now draw half a circle or a quarter of a circle, which goes from, where is this guy? From here. We have to clean this up. But I want to show you something. So I want this to be tangent to that. Let's see if we can make it. This, control that. We can make it tangent. Very good. Now, okay, I'm not going to dimension it. But what I want to show you is this. Let's exit this because it's going to cause a problem. You'll see. I'm going to revolve this line. Okay, so revolve this line about the y-axis by 90 degrees. 90 degrees. Very good. I'm going to revolve this about the y-axis by 90 degrees. About the y-axis by 90 degrees. Preview. Okay. Now, these two surfaces, they have to be joined because they don't talk to each other. If I meshed it along that line, you have different nodes on the left and on the right. Okay? And you have to join. There is no other way. But if you're talking about putting the pressure only once on both, I don't know. You probably have to do it again twice. Okay? So let's see. Let's join these. Where is the guy join? Here. Join this and that. Before, the way I did originally, it won't let me join. But now, because they're different surfaces, they're joined. Let's put material on it. Metal, aluminum, whatever. Okay. And let's see now. We're done here. So we're going to go to generative structure analysis. When you mesh it, everything is going to get meshed. There is no seam around this. Let me make this thing 0.3 and look at your mesh. If you had not joined and you went and looked at, for example, there was a line here, there would have been a line here, and the nodes on the left and the right would not be the same. Because you joined it, you can't even see the line. There is no, actually right here, there is the line, right there. See that? On this line, this line. On this side, node 4546, on this side, 4546. If you did not join that, you won't be able to get, you're going to get a seam along that line, half a circle. Now, the question was not this though. The question was, what happens when you apply pressure? Now, first of all, let's go ahead, deactivate that. Because we joined it, when we apply the thickness, you'll put it everywhere. No problem there, everywhere. But for pressure, let's see. If you apply pressure, I have a feeling that you still have to do both of them separately. This, you see that? Although you joined it, but you have to do that again. So it looks like there's no way to apply pressure at the same time on both of these. If you find out a way of doing it, let me know. Okay? The rest of the problem is the same. Apply the restraint, you know, apply symmetry conditions, etc. It's 4:50, the end of the road. Are there any questions?
I have a question.
Yes, go ahead. Go ahead.
So for the phase connection properties toolbar, the connection, right?
Yeah, you mean this? Face connection? Okay.
Yes.
Yeah.
Yes.
What about it? What about it? What is the question? I don't understand.
The first one is the slider connection, right?
Okay, okay. We never use this. We never use this. You can use it if you want.
Then okay.
We never use this. We use the contact. We use fasten. I didn't use this. I use the shrink fit, pressure fit, and the bolt tightening correction. This, you know, basically contact means that they cannot penetrate each other. Okay. They can still slide, and this is some kind of a variation of that contact. It probably does a few things that you can't do it there. Okay. Let me give you an example. Let me check on this. Let me check on this. Notice that when you do contact, you can specify friction ratio, you can specify no sliding, etc., etc. We never use these, but you cannot do the same thing with slider. Slider means that they will slide without any friction on top of each other, whereas with contact, you can specify the friction coefficient. We never did that, and don't do it, please. We assume that you're living with... What the heck was that?
I haven't been able to access the online
I don't know.
desktop for a couple of days.
Not on my computer.
Okay, wait a minute. What you asked me this? Are you the same person who asked me this question? Are you the same person?
No.
Is that a yes or no? I'm sorry.
No, I came in 3 minutes late. I don't know if you addressed it.
Okay, all right. Somebody else told me that they can't access, you know, whatever. Now, can you? Are you behind your computer so that you can show me what happens when you get the message you cannot access it? Can you show me that?
I can tell you what it says.
Well, wait a minute. Let me make you the presenter. You show me what you see on your screen. How about that? Is that better?
Sure.